Exercise 4.5 is going to have us display a conversion table between pounds and kilograms. So if I look at this exercise, the first thing I notice is that my program will have to display a header for a table. Okay, so display, oops, little typo here, display table header. Okay, so that's going to be the line that reads kilograms, pounds, kilogram, everything aligned correctly. And then I'm going to have to display the rows of the table, display rows of this table. Okay, so to have like kilogram between 1 and 199, I'm going to have to iterate 100 times. Okay, because if you notice the table, you will notice that kilograms start at 1, then 3, then 5, etc. So we're incremented 2 by 2 to reach 199. So display rows of this table is going to mean iterating 100 times. So by iterating 100 times. Okay, so, and this is pretty much all I have to do in my program. Okay, so at this point I need a loop. Which loop am I going to use? Well, the first design question with loops is, do I go for sentinel control or do I go for counter controlled loop? Well, here in this case it's obvious that we need a counter controlled loop. So once this point is out of the picture, the second question is, do I use an early test loop, for example for or while, or do I use a late test loop, for example do while? Well, it boils down to asking yourself, does it matter whether I do my iteration loop body at least once or not? If it doesn't matter, I can use any loop, and this is the case here. Okay, because it is a counter control loop, I'm going to try to use a for loop because they are really well adapted to do this kind of job. So the for loop has 3 components between parentheses, okay, and then the body of the loop. So I have my skeleton here. What do I need to do? I need to iterate 100 times. This should be a no-brainer by now. To iterate 100 times, okay, this is a counter-based loop pattern pretty much. I'm going to start with a variable I at 0, iterate until I is lesser strict than 100, and at the end of each loop I'm going to increment I by 1. Okay, so this should be like clear by now, no hesitation, no doubt. Okay, we did that many times already in the past in this class. So there is the body of my loop. I need to display the table header. Well, system.out.println, I'm going to display on one single line. What am I going to display? Well, I'm going to display kilograms, okay, and I want some spacing here. Rather than put a certain amount of white characters to space, I'm going to use a tabulation. Kilogram, I'm going to display how many pounds the kilogram in the first column are. Then I'm going to display a value in pounds again, and I'm going to display how many kilograms are in those pounds. And I can close here my string. So this is going to be one line. Inside of my loop, I need to do similarly system.out.println, and I'm going to have to display several things. Okay, so one line of my table is going to contain what? A value expressed in kilogram, 1, then 3, then blah 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 up to 199. Then the conversion of this value in pound. Then a value in pound starting at 20 ending at 515, and a conversion in kilogram of this. So right now I'm stuck. I need more variables. So I'm going to close my println for now. I need a variable what? I need a variable kilograms and I need a variable pound. Let's call them like this, okay? Or actually let's abbreviate them into K and P. So I need some kilogram int K, and I need some pounds. What are the values these need to be initialized to? Well, kilogram needs to start at 1 in my display, and pounds need to start at 5. So I can use here a neat feature of the while loop. Okay, in my initialization part here that will be executed before I start the loop, I can have several variables declared or initialized. So I choose here to initialize kilograms and pound in this section of the for loop. Okay, it's not necessarily readable. I would not recommend it for beginners, but it's just to show you what you can do with a for loop so that you understand it once and for all. Then what? Then I need to display here, well, I need to display the value of K, followed by a tabulation. And I'm going to start spacing things here because there's going to be much more coming up. So this is going to be my first line. Okay, this first line will be followed by, what am I going to have? here. I'm going to have the value of K converted into pounds. How do I do this? Well, I take K, multiply by 2.2. This is given to me in the exercise. And I follow this by a tabulation once again. Then what? Next line will be the value of pound, followed by a tabulation as well. Oops, little typo here. And then the last part, the fourth column, will be this value of pounds divided by 2.2 to convert it into kilogram, and followed by nothing. Actually, I'm going to end my line here. Okay. So let me see. I have my variable initialized. I'm going to iterate 100 times. What's missing? Well, I never change the value of K and P. So if I don't do anything about that, these values are invariant in my loop. They never change iteration after iteration. So I will doubtfully have the column kilogram vary from 1 to 3, etc. So I need to increment those. Most naturally, I would expect you to start incrementing those variables at the end of your loop after the print ln statement here. I want to show you that you can do it also inside of this for loop, simply by writing here K plus equal 2, kilogram increment 2 by 2, and P plus equal 5, pounds increment 5 by 5. So this is where we stand. This is another trick of the for syntax. You can have more than one variable incrementation automatically done at the end of each of your iteration. Okay, so let's save this and let's try to figure out how it works. So Java C, exercise 4.5.java. Okay, couple of syntax error. K is already defined in main. Alright, here's what's happening here. When I use this syntax as a for, this is declaring already variables K and P inside of the loop. So every variable that you declare like this here is going to be valid only in the body of this loop. So it won't exist outside the loop. So that can be a problem sometime. For us here, since we're not going to use K and P outside of this for loop really, we don't need them outside the for loop. So by writing the declaration here in the for loop, we make sure that those variables exist only for the body of the loop and disappear as soon as we reach the next instruction after the for loop. Well, that's fine for us. Sometimes it will not be adapted to what you're trying to do. You will have to be able to access the value of K, P, I, etc. outside the loop. In that case, you would not declare them here. You would declare and initialize them there. Okay? So let me save. Let me go back to Conqueror. Let's try to compile again. Well, this time it's compiling a lot better. Exercise 4.5. We iterate. Let me see the beginning to see if our header is correct. Okay, the header looks like kilogram. Well, this is not exactly what we typed here. This is a previous test. Let me scroll down a little. There we go. Kilograms, pounds, pounds, kilogram. This is actually aligned with the first column. This is not aligned with the first column. What happened is that kilograms is too long. So when we add the tabulation, we go here. When a short value is displayed, you add a tabulation, you arrive here. So we'll have to work a little on that, okay? Abbreviate kilogram or add one extra tabulation, something like that. Pounds is aligned, so we have some work to do. Another work we have to do is that we are displaying those numbers with an inordinate amount of places after the decimal point, okay? This is not what the textbook is doing. So our formatting really right now is in need of some fixing, okay? We'll keep that for the end. Right now, is our code working as expected? Well, let me see. We start at 1 for the kilograms. Let me scroll back up. There we go. We start at 1 for the kilogram and 5 for the pounds. Oops, little problem here. I should have started at 20, so I'm going to fix that. Then what? Then I finish at 199 for the kilogram, which is correct, and I finish at 500 for the pound. Well, I should be finishing at 515, which would be okay, which would be the case if I started at 20 instead of 5. So I'm going to fix that immediately. Let me go back to my code. There we go. We are going to say that the pound start at 20 instead of 5, and that will correct our problem. Well, now what about the formatting? Well, here's the choice that we have. Let's say that we keep it one single tabulation here. We can, after we display the value of kilogram, put 2 tabulation instead of 1. That would be one solution. Another solution, abbreviate kilogram. Well, let's go with 2 tabulation here to see how this works. Okay, so I'm going, this is just layout formatting issue here. It's not really critical, but this is going to give us an opportunity to learn how to use those print and println statements a little better. So what is going on now? Let me scroll up. The spacing for the first column is okay. It's huge, but once again it's because kilogram is a long word. So kilogram, a tabulation, then our number, 2 tabulation. But then again we have the same problem here with pounds. Okay, so we are going to need to put an extra tabulation here for pounds. So I'm going back to the exercise. I display the value of kilogram, I display the value translated in pounds, and then I'm going to add an extra tabulation. So let's see how this look. Go back to Conqueror. I need to scroll down to my prompt. Only if it decides to let me do that. There we go. A little bit of problem here. Let me look into that real quick. Okay, took a little bit of shaking here to fix that. Java C. Java. Okay, we have columns that are a little better aligned, but they're still not working the way that we want to. What is going wrong here? Well, this time it's the number of places after the decimal point that are causing us problem. Okay, Java is displaying, like I said before, a lot of places after the decimal point, which cause all of our column to be disaligned. So we're going to go back to the code and we're going to try to fix that. This time, in order to fix that, we are going to have to edit here and replace our call to println with a call to the function printf. Little problem here with the cut and paste. Let me fix that. Okay, so I'm going to go ahead here, and instead of println, I'm going to use printf. How does printf work? Well, printf is going to do the same job than println or print, but with a slightly different syntax. Printf always starts with a formatting string, followed by, well, all the value that you want to display. So we are going to display the value of k, okay, and then separated with a comma, I'm going to specify that I want to display the value of k times 2.2. That's going to be my second column value. And then I want to display what? I want to display the value of p, followed by the value of p divided by 2.2. So this is how printf is operating. Okay, you specify all the value you want to display, and before them you specify a formatting string. So this formatting string is going to tell us how I want to display those value, in what order, etc. So to display the value of k, which is an integer, I use a special code, %d. Okay, so wherever I type %d in this formatting string in printf, this %d will be replaced by the value of k. Then my next value is k times 2.2. This is a value I wish to display as a float. Okay, so this is going to be %f. %f is a printf code that allows me to display a float. Then %d again for the value of p. Then %f again for the value of p divided by 2.2. So this is how it works. You specify all your value, how they are going to be displayed. So this is formatting concern, and then you specify the expression or the variable that you want to use to display those values. So k times 2.2, p divided by 2.2 in our example. Okay, so in printf, when you want to go to the next line, you specify it by \n. If you want to put tabulation between those number, you can simply add your tabulation here like this. Okay, so it's all attached. It's kind of hard to read, but these are codes that tell printf how to format things. So I'm going to save and test, and then we'll add an extra tabulation wherever needed. Okay, depending on the result we get on the screen. Run the code. Well, it's a little better than what we had so far. Okay, the columns are inherently correctly aligned. Okay, except once again for that kilogram problem here. So I'm going to have to add an extra tabulation here, and probably that's going to be it. Okay, so this is okay. Now what about the number of places after the decimal point? Well, we are going 6 places here. This is a default for printf. This is a default way printf displays a floating point number on the screen. So we can change that. There's a little bit of syntax. So when we display a %f, between the % and f, we can type 2. A02, sorry, which is going to allow us to say I want 2 decimals after the decimal point, 2 places after the decimal point. And then, like I said, I want to add another tabulation here. Let me save, and let's see how much closer to our objective this brought us. So Java C, compile, and then run the code. Okay, it looks good. 2 places after the decimal. Look at the alignment up here. Kilograms, pounds, kilogram. I need another extra tabulation here. So I'm going to go back to the code. And at that point, we have the program working. Okay, all we are doing is trying to make sure we display things as they are requested in the code, which is generally what you do at the end. Once your algorithm, your code logic is already functioning. So let's go at it again. Okay, I made a little bit of adaptation here. There is another tabulation that has been added right here. Now it's aligning almost correctly. There must be a white space here that is extra before pound and kilogram. I'm going to fix that, and I could use another tabulation once again here. So I'll go back to my code, probably the last iteration. I'm adding a tabulation here, and what is going on with pound, etc.? Well, this is what's going on. Okay, after the tabulation I add an extra space, so I get rid of that extra space. I save. I'm going to recompile again. I'm going to execute again. Check my alignment. Okay, it's a little better, except that, and this is where it gets kind of annoying now, except that because I removed that extra space, now everything here has been shifted to the left. So I'm going to add an extra tabulation here, and I'll probably need an extra one here too in the title line. So the columns are fine. Okay, it's just taking some trial and error to get right the alignment. So tabulation here, tabulation again, that's what I just mentioned, tabulation again. Let's see how it looks. Java C, Java. Okay, everything is spaced evenly already here. We had that previous time. Everything is perfectly aligned for the header of the table as well. So we're pretty much done. Okay, I'm going to show the code again, and we're pretty much done with this exercise.